Now students, we will start chapter number 4, basic geometrical ideas, with the exercise 4.1. So first question is, use the figure to name. Now here the figure is given to you. According to this figure, we have to write down the naming of this figure. So 5 points. So which are the 5 points we can see over here? So point D, E, O, B and C. D, E, O, B, C. These are the 5 points we can see in this figure. Then which are the lines formed? Now we have already learned line can be extended in both the direction of your line segment. So this is point line segment D. Now if you extend this line on both this direction, it will form line DE. Then if you take EB, this is E and this is B, it can be also extended in both the direction. So line EB. Then line DB, this can be also extended and that side also be extended. So line DB. Then let us see EO. This side it can be extended and this point can also be extended. So line EO will also form a line. So there are the other lines also we can form. Now question number 2. Name the line given in all possible 12 ways, choosing only 2 letters at a time from the 4 given. Now a line is given to you A, B, C, D. We have to choose 2 letters and we have to make the line, and 12 possible ways. So first line it will be line AB, then line AC, then line AD, then BA, line BC, line BD, then line CA, line CB, line CD, then line DA, line DB, line DC. So these are the 12 possible ways. Now we will move to the next question. Now the third question, use the figure to name. A, line containing point E. Now a figure is given to you. You have to find out which line contains point E. Now this is point E. Now this line, the line is AE. So we can write down line AE contains point E. Even this E, it passes through line EF. So line EF also contains point E. Now line passing through A. Which line passes through point A? So line AE, or we can say line BE. Any of the line passes through point A. Rest of the 2 sums you can do it by yourself. Now question number 4. How many lines can pass through a given point? So from one single point, how many lines can you pass? Suppose I am drawing the line like this way, this way, this way. You can draw so many lines from a single point. That means you can draw infinite lines from a single given point. Now how many lines can pass through 2 given points? Now 2 given points, this is one point and this is second point. 2 points are there. So how many lines we can pass? One and only one line we can pass through the 2 given points. So the answer is one and only one. One and only one line we can pass to the two given points. We will move to the next question, that is question number 5. Now question 5. Draw a rough figure and label suitably in each of the following cases. Some sentences are written over there. According to that situation, we have to draw the rough figure. Point P lies on line segment AB. Now you can draw a line segment AB. This is line segment AB, and you have to draw point P. That means it lies on line segment P. So this is the answer, line segment AB, and on line segment AB the point P lies. Second, line XY and line PQ intersect at M. So I am drawing line XY and line PQ. Line XY and line PQ intersect at point M. That means it meet at M. So rest of the sums you can do it by yourself. Now the next question number 6. Consider the following figure of line MN. See whether the following statements are true or false in context of the given figure. Now a figure is given, a line is given MN. Now according to this figure you have to write down true or false. So the first statement, QMONP. QMONP, they are on line MN. As I already told you, a line can be extended. So this is your line MN. If you extend, it will go in both the direction. So the answer for the first statement is true. Now B, MON are the points on a line segment MN. This is line segment MN. Line segment MN is formed by the 2 points, that is fixed point MN. So which are the points? M, O and N. M, O and R. These are the 3 points on line segment MN. So again this statement is true. Rest of the true or false you can try it by yourself. Now let us see exercise 4.2. The first question, classify the following curves as open or closed. We have to write down which curves are open and which one are closed. We have already seen, if you start with a simple point and you end up with another point, that means it does not meet with each other, then it will be an open. And if you start from one point and you end with that point only, then it will be a closed curve. Now looking at this figure, you have started from here and you have ended over here. So this curve will be your open curve. Now this curve, suppose you are starting from here, you are making a curve and you are ending over here. So this type of curve is closed. Rest of the figures you can do it by yourself. Now let us move to the second question. Draw rough diagrams to illustrate the following. Open curve. You can draw the figure of open curve as you wish. So if I want to draw, I will draw an open curve like this way. Second is closed curve. If you want to draw, this will be your closed curve. I have joined both the points. So this was about the closed figure. You can draw it by yourself according to your choice. Third question, draw any polygon and shade its interior. We know polygon is made up of entirely line segments and we have to shade its interior part. So I am drawing a polygon of this. Okay, this is a polygon of 1, 2, 3, 4, 5 line segments and I am shading its interior. Interior means inside portion. So I am shading it with the chalk, and this was the shading part of the interior. So this was about question number 3. Question number 4. Consider the figure and answer the question. Now a figure is given, you have to consider this question and you have to write down the answer. Is it a curve? Now curve means a bending. Okay, we have to start a figure from this way and it should bend anywhere. So I have started from here and it is bending over here on both the 4 sides. So this will be a curve. So we will write down yes, it is a curve. Is it closed? Yes, all the sides it is closed. So this curve is closed. So this was about question number 4. Now let us move to the next question 5. Illustrate if possible each one of the following with a rough diagram. Here we have to draw the rough diagram. First one, a closed curve that is not a polygon. We have to draw a curve which is not a polygon. That means it should not be made up of line segments. So we can draw a simple curve and it should be closed. So this is a closed curve which is not a polygon. Second, an open curve made up of entirely line segments. So we have to draw a curve we will draw a curve. So this is an open curve which is made up of entirely line segments. So this was about question number 4 and question number 5. Now we will see exercise 4.3. First question, name the angles in the figure. A figure is given A, B, C, D. Now we have to write down the angles. So we will start with angle ABC. Angle ABC, or we can say angle B. Then angle BCD. BCD, or we can say angle C. Then angle CDA, or angle D. And next angle DAB, or angle A. So this way we can form the angles from the following figure. Now second question, in the given diagram name the points. First point in the interior of angle DOE. This is DOE. This is angle DOE. Which points in the interior? Interior means inside. So point A is in the interior of angle DOE. Second, in the exterior of angle EOF. This is angle EOF. So the points which are exterior, point A, point D and point C, they are exterior of angle EOF. So C, A and D, these are on the exterior of angle EOF. Now on angle EOF. EOF. So which points lies on angle EOF? So points E, point B, point O and point F lies on angle EOF. Now the third question is, draw a rough diagram of the two angles such that they have first one point in common. Suppose I am drawing a one line. Okay, so one point common. So angle MOA and angle NOB have one common point. The common point is O. Now let us see the second, 2 points in common. Now angle ROP and angle OPC. Angle ROP. So this is the common point O and angle OPC. So this is P is the common point. So we have seen 2 points in common. Rest of the things, questions, you can do it by yourself. Now let us see exercise 4.4. The question I am reading out. Draw a rough sketch of triangle ABC. Mark a point P in its interior and a point Q in its exterior. Is the point A in its exterior or in its interior? So let us draw a triangle ABC. ABC. Now according to the question, mark a point P in its interior. Interior means inside. So I am marking a point P in its interior and a point Q in its exterior. Exterior means outside. So I am marking a point Q which is outside. Now is the point A in its exterior or its interior? You can see a point A. So A is neither interior nor exterior. So A is neither interior or exterior. It lies on triangle ABC. So it lies on triangle ABC, point A. Now let us move to the next question, number 2. Identify 3 triangles in the figure. A figure is given, you have to identify the 3 triangles. So the 3 triangles we will write down as triangle ABC, triangle ABD and triangle ADC. After that, so these are the 3 triangles. Write the names of 7 angles. So we will write down the names of 7 angles. Angle ABD, angle ABC, angle BAC, angle DAC, angle CAD, angle ABD and angle ADB. So these are the names of 7 angles. The third question, C, write the name of 6 line segments. So we will write down the name of 6 line segment. Line segment AB, line segment AD, line segment AC, line segment BD, line segment DC and line segment BC. These are the name of 6 line segments. D. Which 2 triangles have angle B as common? Now which 2 triangles have angle B as common? So triangle ABC and triangle ABD. So angle B is common in angle triangle ABC and triangle ABD. So this was about exercise 4.4. Now let us move to exercise 4.5. I am reading out the question. Draw a rough sketch of a quadrilateral PQRS. So we will draw a quadrilateral. Quadrilateral is made up of 4 sides. PQRS. Draw its diagonals. Diagonals means the points which meet opposite to each other. So here the diagonals are line segment PR and line segment QS are the 2 diagonals. Name them. So I have already named it. Is the meeting point. Let us write down the meeting point and name it as O. So is the meeting point of the diagonals in the interior or exterior of the quadrilateral? Here the meeting point O, it is in the interior. So we have quadrilateral PQRS. The 2 diagonals are line segment PR and line segment QS, and O is the meeting point which is in the interior of the quadrilateral. So this was about question number 1. Now let us move to the next question number 2. Draw a rough sketch of a quadrilateral KLMN. So we are drawing a rough sketch. This is K, L, M, N. A rough sketch of a quadrilateral. State A, two pairs of opposite sides. Opposite sides we have to write down. So let us take line segment KL. Opposite to KL is line segment NM. And second pair is line segment LM. Opposite to this is KN. So these are the two pairs of opposite sides. B, two pair of opposite angles. So angle L and angle N. These are the two pairs of opposite angles, and another pair is K. Angle K is opposite to angle M. So this was opposite angle. Now let us see two pairs of adjacent sides. Adjacent side means baju ki sides. So let us take line segment KL and line segment KN. These are the two adjacent sides. Let us take LM, line segment LM and line segment MN. These are the two adjacent sides. Now let us move to the D. Two pairs of adjacent angles. Angle K and angle L. These are the two adjacent angles, and we can name any other angle, that is angle M and angle N. They are also adjacent angles. So this was about exercise 4.5. Now we will see exercise 4.6. The question is, from the figure identify. A figure is given to you. From that you have to identify the things. First one, the center of the circle. The center of the circle you can see is O. So the center of the circle we will name it as O. Then let us see B. Three radii. Here radii is a plural form. So the three radii you can see is OA, OB and OC. That means from the center it meets to the point on a circle. So the three radii we can see is OA, OB and OC. Now third, a diameter. Diameter means from the center it connects the 2 points on the circle. So diameter is your line segment AC. Fourth, D, a chord. Chord also connects the 2 points on the circle. So ED is the chord of the circle. Now let us see E. 2 points in the interior. The points which are inside the circle. Point O is in the circle and point P is also in the circle. So O and P, they are in the interior of the circle. Now F. A point in the exterior. Exterior means outside. Outside the circle you can see the point Q. So point Q is outside the circle. G, a sector. Sector you can see it is made up of a radii and an arc. So OAB, this is a sector. H, a segment. A segment is made up of a chord and an arc. So this is the segment. The name is ED. Now let us move to the next question. A, is every diameter of a circle also a chord? Yes, we have already seen a diameter can also be a chord of the circle because it meets at the 2 points on the circle. So we will write on yes, if the diameter can be of a circle also can be called a chord. B, is every chord of a circle also a diameter? Now diameter always passes through the center, but this chord, this is over here. So we can say that every chord of a circle cannot be called as a diameter. So the answer for this will be no. Every chord cannot be a diameter of the circle. Now let us move to the third question. Draw any circle and mark. So here we have to draw a circle and we have to mark out the points. Suppose I am drawing a circle. Now, first its center. So I am marking this point as a center and I am naming it as O. So the first point we will write on here, its center will be O. Now let us see B, a radius, a single radius we will see. So let us name it as OA. So OA can be called as a radius. C, a diameter. Let us see the diameter. So I am connecting from this to this. So let's AB can be called as a diameter. Now D, a sector. Sector is formed of a two pair of radii. So I am drawing over here and I am marking this C. So OA and OC are the two radii. So OAC can be called as a sector. E, a segment. A segment is formed of a chord and an arc. So this portion, I am writing it as E and F. So this portion can be considered as a segment. F, a point in its interior. Suppose I am marking a point, a single point I am marking because a point is given, I am writing as P. So we can say P can be called in the interior of the circle. Then G, a point in its exterior. Suppose I am marking Q over here, which is outside the circle. So point Q is outside the circle. H, a arc. Suppose I am drawing with this as other chalk. Arc means a curve. Suppose I am writing it as MN. So H can be your MN. This is a small arc and we will draw it in a symbolic form, that is arc MN. So this was about question number 3. Now let us move to the next question. 4. State true or false. First one, two diameters of a circle will necessarily intersect. Yes, let us draw two diameters of a circle. This is one circle and this is another circle. So it will intersect each other at a common point. So the first one for fourth one is true. Now let us see the second one. The center of the circle is always in its interior. Yes, obviously the center of the circle, suppose this is a circle and this is the center, it will always lies in the interior. The second statement is also true. So students, this was about chapter number 4, basic geometrical ideas. So I hope that you have understood all the concept of chapter number 4. So thank you.